So in continuation with the common robotic configuration what all it's available, we'll discuss further. So when we take a articulated robot, so here you can see the polar configuration robot. Also in the articulated robot, here you can see all the three axes will be having the rotation of the robot, and there is no linear motion. So here the given number of joints, it is 5 into 5 into 5, it is 125 possible combination of the joints. The body and arm assembly for 3-axis manipulator it's available. There are design variations within the individual joint. It is somewhat remarkable, there are only few configurations are common. But if you take in the polar configuration, here there is one linear motion and two rotary motion with respect to joints in case of polar configuration type of robot. So if we take a SCARA robot, it is a polar type of configuration robot. Here you can see one is the jointed movement, that is here vertical motion is available. There are two rotary motions. And if it's a Cartesian robot, here you can expect motion in all the three directions, that is X, Y and Z. It is possible. Further, if you take delta robot, and the delta robot here, all the three arms are connected to a small portion, a small platform below. So end effector is usually attached, is usually attached in the two-dimensional form. So like this different type of robots are available for installation in the company. So further, if you take the bridge configuration of the robot, there are three bridge configuration of robot. One is the roll, second one is the pitch, and third one is the yaw. So in the first case, that is the roll, here it is meant for rotary motion to screw and unscrew actions. This type of motion is used in the robot. And third is the pitch. It involves up and down rotation of the robot, and if it is yaw means it involves right and left rotation of the robot. So here the letters are indicated, that is L, O, R and R, T and V, to indicate the type of motion which has to be done. So the joints are driven with the help of robot. One is electric, hydraulic and third is pneumatic. The electric drive we are going to use different type of motors. It may be a servo motor, stepper motor. Based on the need, you are going to decide. Suppose if it is hydraulic means hydraulic and pneumatic drive means it will be linear pistons and rotary vane actuators. If it is pneumatic, here air is used instead of water. So by pneumatic drive, we will be able to make the motions of the robotic arm structure easily. So here electric drive robots are more accurate compared to hydraulically powered robots. Hydraulic drives are designed by greater lift capacity. So like this electric type of drive system, it is used more compared to hydraulic and pneumatic. So different type of sensors used in the robot is tactile sensors, proximity sensor, optical sensor, machine vision and other sensors. So here sensors are categorized into two parts. One is the internal and external sensors. So here internal sensors are meant for to feedback control loop. So here the typical sensors are used for position of the robot arm, including potentiometers and optical encoders. Tachometers are also used to control the speed of the thermo of the robot arm. If it is an external sensor, they are used to coordinate the operation of the robot with other equipment in the cell. These external sensors are relatively simple devices such as limit switches that determine whether a part has been positioned properly in a fixture or that a part is ready to pick up at a conveyor. Other situations require more advanced sensor technologies, including the following: tactile sensor, Tactile sensor, it is used to, as soon as it touches, it is going to sense. Force sensors are used to measure the forces. Proximity sensor, it is used to check the objects within the specified range. Optical sensors are used to detect presence of or absence of objects nearer to the machine. Machine vision, it is used to go for inspection, part identification, guidance, and other uses. If it is other sensors where all you want to add based on the requirement, for example, temperature measurement, fluid pressure measurement, fluid flow measurement, electrical voltage measurement, current, and various type of other physical properties. So like these sensors are used in robots. How do you control the robot? By using the control system. So the controller are classified into 4 categories. One is limited sequence control, second one is playback point-to-point control, playback with continuous path, and intelligent control. The limited sequence control is used for only simple motion cycles. If it is playback, means point to point. Playback robot represents a sophisticated form of control than limited sequence robot. Playback control means that the controller has a memory to record the sequence of motion in a given work cycle. Means here the point-to-point control, it indicates linear motion in the work cycle during the execution of the program. Playback with continuous path. So here continuous path means where all curvatures are there, where all contours has to be generated, that it has to make a decision. So it has to move in steps so that required output is achieved. So for that, interpolation calculation is required in the machine. So without interpolation calculation, you cannot go with the exact impacts. So intelligent control, it is meant for robot appear intelligent, includes capacities to interact with its environment, make decisions when things go wrong during the work cycle, communicate with humans, make computations during motion cycle, and responds to advanced sensor inputs such as machine vision. So end effector of a robot, here it's a robot mechanical gripper is shown. So at the end where motion happens, it is made up of magnet. It can hold the workpiece and it can release it. So this is the gripper where it is going to hold like the finger like structures. So it can accommodate different parts, different finger attachment can be made. Sensory feedback of the finger that provide gripper with capabilities such as it must sense the work part, apply specified limited force to the work part during gripping so that holding of the work part becomes easy and transferred to the next place. So on the end effector, what all you add, you can add different operations to different attachments to go with the processing operation on the work part. So here robots are in wide field of application in industry. One is material handling, second one is processing operation, third is assembly and inspection. So like this it keeps on going. So what is material handling application is, so it may be pick and place, you have to move from one machine to other machine. So like this material handling applications will be done by the robot. So material transfer also can be done, means you can do pick and place once the operation has been executed. So the high speed picking and packaging operations can be done. Machine loading and unloading can be done. While die casting also you can do. Once casting has happened, transfer it to the water bath for cooling. In plastic injection molding you can use. Metal machining operations you can use. Forging operations you can do. Press working operations you can do. Heat treating operations can be done. Where you feel human work is hazardous, you can substitute with the robot and get the required work done by the robot.